All right, my friends, let's take a look at part A here. You can see a product of two of tangent and secant where they're both to different powers. So this would be one where you try use substitution, and you could either let u equal tangent of x, or you could let u equal secant of x. And every once in a while, both of them will work. So let's see, I'll just say versus. All right, we'll just play with both here. So if u is equal to tangent of x, then your du would equal secant squared x dx. So let's go ahead and go down this road, and then we can look at the other option here. Okay, so I'll rewrite the problem. So it says tangent cubed x, and then we'd have secant x, and then we'd reserve that secant squared x dx off to the side. So I just rewrote the problem, secant cubed. I just split it up as secant times secant squared. And so let's think about, like, is math telling us yes or no with this idea? Whoops. Okay, so tangent cubed would be u cubed. This looks easy. Secant squared dx, that's my du. And then secant x, you wouldn't be able to Pythagorean swap your way out of that. And so it's right there that makes me think that this is not the way to go for this problem. Okay, so now let's try letting u equal secant. So what would my du be? Derivative of secant is secant x tangent x dx. Okay, so let's look at the original problem. I'm going to write secant cubed first. And then, actually, not secant cubed, sorry. I need to save secant tangent off to the end. So I'm going to take one of those secants. So I'm going to write secant squared first. And then I'm going to save one of the secants off to the end. And then the same thing for tangent cubed. I'm going to split that up as tangent squared x. And then the tangent x at the end. Okay, so I've got secant x tangent x dx reserved as my du. Secant squared x, that's easy, that's u squared. And then the reason math is telling me yes right now is because tangent squared, since I've got tangent to an even power, I can Pythagorean swap my way out of, that. I can Pythagorean swap my way into an expression in terms of secant. And so tangent squared is equal to secant squared x minus 1, which could be swapped out for u squared minus 1, like so. Okay, so the integral written in terms of u would be u squared times the quantity u squared minus 1 du. All right, distribute. We'd have u to the fourth minus u squared. Back substituting, we let u equal secant, so we'd have, antiderivative would be u to the fifth over 5, but let's back substitute at the same time. So secant to the fifth x over 5 minus secant cubed x over 3, and then plus c. Just a comment, this could be very easily written in terms of cosine, since secant is 1 over cosine. So if you check your answer in the back and they have something like this in terms of cosine, you just need to show that your answer is equivalent to theirs, kind of like a verify the identity problem. There we go. All right, let's look at part B. Part B, let's see, what if we, let u equal... if I let u equal tangent, I'd need to save a tangent secant off to the side. And so I'd have like an extra secant I wouldn't know what to do with. So let's see what happens if we let u equal, oh no, wait, did I say that funny? No, actually, no, I back up. If I let u equal tangent, then this thing works out really well because my du would be secant squared x. Oh, come on, that's so cute. Oh my goodness. So this is u squared, and this is du. Oh my goodness. All right, so that's the easiest thing ever. So power rule, back to substitution. tangent cubed x over 3 plus c. Yay! There we go. Okay, so that one fell into our laps pretty easily. Now for part C, I would dedicate part C, I think, to if all else fails, just turn everything into sine and cosine. But you wouldn't want to do that all the time. Like if you look at the, other problems, that wouldn't especially have been a great idea. But let's see what happens if we do with this one. So let's see, tangent squared would be sine squared over cosine squared. Secant to the fifth is 1 over cosine to the fifth x. Okay, flip, multiply, cancel. So the cosine squareds would cancel after you flip and multiply. And so you'd end up with sine squared x times cosine cubed x dx. There we go. All right, from here, you could let u equal sine or cosine. I think we'll have more luck with letting u equal cosine. All right, so let's see what would happen. Let's see. Or no, we would not have any luck with letting u equal cosine, would we? Not at all. Not at all. All right, let's let u equal sine. There we go. Okay, so let's see. This would be u squared. This we would break up as cosine squared times cosine x dx. So let's see, I'll write it like this. There we go. Okay. Now, writing this in terms of u, this would be u squared. This would be 1 minus u squared because of a Pythagorean swap, and that's du. Boom. All right, power rule. Let's see, u cubed over 3, and I'm going to back substitute. So I'd get sine cubed x over 3 minus sine to the fifth x over 5 plus c. There we go. All right, my friends. So I hope that if I was to back up and you saw me let u equal cosine, and then I went down that road and realized that it wasn't going to work, that's likely how that's going to work for you too. Where you try something, maybe even in your head, you don't even let the pencil start writing your idea, but you think down a couple steps and you think, no, that won't work. Okay, so that's part of it. I just want you to know that. All right, my friends. See how example 4 goes. Solve the differential equation. Y prime times cosine to the fourth x equals square root of tangent x. Good luck.